So it's super easy to connect an old Atari joystick to an Arduino. If you're in a rush or you're not interested in the background, there's a TLDR at the end of this video linked below. Otherwise, first let's start with a quick explanation of how the joystick actually works so you can better understand how it works with the Arduino. So inside the joystick, it's a really simple breadboard and switches. It's not even really electronics, it's basic circuitry. The way it works is that current is pumped by the Atari into 5 different pins of the connector and down through wires into the board. But the only way any of those wires will actually complete a circuit is if one of the switches on the board is pressed. Each switch is pressed by either the joystick moving up, down, left, or right, or by the fire button being pressed. This is actually the heart of the matter. The Atari, and soon your Arduino, knows when a specific button or joystick direction is pressed because there's a voltage drop on the relevant pin. So how do we connect the joystick to the Arduino? Well, when you look at the female plug at the end of the Atari joystick, the pins are numbered from right to left, top to bottom. Pins 1 through 4 are up, down, left, and right, respectively. We don't need to worry about pin 5. Pin 6 is the fire button. You're not going to use pin 7. Pin 8 is ground, and pin 9 you also won't use. The pins are right to left because they mirror the pinout on the console where it would read left to right. So here's my Arduino. I've connected pins 1 through 4 and pin 6 from the Atari joystick plug to digital pins 2 through 6 on the Arduino. You can even just shove the jumper wires that come with the Arduino Uno starter kit right into the holes of the Atari joystick connector. You can kind of snap them into place, although the connection is broken fairly easily. It's not a huge deal, it's just annoying. You're not going to explode your Arduino or anything if this happens while the Arduino is plugged in. Finally, connect pin 7 directly to your breadboard's ground. As a means of testing everything, I wired 5 digital pins, starting at pin 9, out to the breadboard. Each pin connected to an LED and a 220 ohm resistor, and then back to ground. And the ground connection was patched from the main Arduino ground pin. I arranged the red LEDs in a pattern that could visually represent up, down, left, and right for easy debugging, and then a yellow LED to represent the fire button. The important thing here is to note which pin you connect to which LED. For the sketch that I wrote, I used simple addition to determine which pin gets a signal. If pin 2 notes that it has a completed circuit, the Arduino will send a high or on command to the pin that is 7 pins higher, i.e. pin 9. Pin 3 talks to pin 10, pin 4 talks to pin 11, etc. So make sure that you wire pin 9 to the LED that's highest in your field of vision, so that when you push up on the joystick, the LED that's highest in your field of vision lights up. Pretty simple. Okay, so now for how to program your Arduino. Remember before when I mentioned that the Atari, or your Arduino, knows which switch has been pressed and completed a circuit? Well, when you complete that circuit, it results in a voltage drop because of the connection. So the way we need to program our pins is that when they do not experience a voltage drop from the plus 5 volts, they're registering false, and they'll register true when there is a voltage drop. The way you do this is simple. When you assign the pin mode in your script, rather than assigning it input or output, you're going to assign it input pull-up mode. This will output voltage from each pin as if it were in output mode, but it also reads the pin to determine if there's a drop in voltage. It's actually pretty cool. So there's a link in this video's description below to the sketch on GitHub. In the sketch loop function, it basically just checks the voltage being output on each pin. If any pin registers a voltage drop, the sketch then takes the numeric value of that pin, adds 7, and outputs a voltage to the pin corresponding to that new value, lighting the appropriate LED. The resistor then completes the circuit and prevents the LED from being overloaded. So here's the TLDR. Connect the Atari Joystick's pinouts 1 through 4 and 6 to their own digital pins, 2 through 6 respectively, on the Arduino. Connect pin 7 to the ground on your Arduino. Connect pins 9 through 13 to the LEDs that you would like to correspond to up, down, left, right, and fire, respectively. Make sure to connect both the LED circuits and your Atari joystick to proper ground. You do not need to run +5 power to your board, even though my photo says otherwise. Now your Arduino knows how to talk to an Atari joystick. Enjoy!